Hey guys, so we are in lesson 7, and we're not doing as many videos in this class right now because we're doing a lot of stuff in class, going over like the individual lessons. So we've done 1, I think we did 2, we skipped 3, we did 4, we did 5, we skipped 6, so now we're on to 7. Measuring variability for skewed distributions, and this is the word that we want to take a look at. Interquartile range. The word quartile is very similar to the word quarter, right? So there are going to be 4 different ranges that we are looking at. When we see the word interquartile, you need to understand that if it's talking about interquartile, we're going to make a box and whisker plot. I hope I knew how to spell plot, okay? So a box and whisker plot has something that looks like this: a whisker, a box, and a whisker. Inside of that box somewhere is a line. So what this really is I'm going to put first, second, third, fourth. In a box and whisker plot, we have 4 quartiles. 25% of our values are in between the lowest and the edge of our box. The interquartile is in between those two. 50% of our numbers are in between those lines, which means 25% are here, 25% are here, and 25% are there. The line that you see in that interquartile range is the mean. That is the average of all of our numbers, okay? So right now, we're going to be making a box and whisker because a box and whisker gives me a lot of good information. So taking a look at this exploratory challenge, first off, it's a little bit different because when we look at this, we can't be exact. Normally, you would have like 2, 4, 6, 8, and then 10, but it's 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There's 5 things in between. I don't know what these numbers are. So I did my best. Now, what we learned last time, and when I say last time, yesterday in lesson 6, was how to do standard deviation with our calculator. We do box and whisker plots the same exact way. We start off by pressing stat, we go to enter, we clear whatever else is in list 1. Okay, so right now, I've pressed stat. I'm now in my list 1. I have entered in all 80 of these numbers. Okay, I did this beforehand. So 76, 77, there's my 80th, and then it's blank. And it does say there's 80 numbers, there's 80 viewers. These are all the ages. Once I have this, the way that we found our standard deviation is we pressed stat again. We go over to calculate, and then it says 1 var statistics. We press 1 var stats. It says list L1, absolutely. Calculate, yes, please. And then it gives me my mean, and it gives me my standard deviation, and it does all that for us. What we're looking for now is a couple things. If it says 80 viewers, N better be 80, and you move down to see that. So maybe you can see that, maybe you can't. But then we have a minimum, we have a Q1, we have a mean, we have a Q3, and we have a max, okay? So when I'm looking at these, this is going to help me very, very well. Remember, X bar, X hat is my mean. So approximately, yeah, it says approximately, that's wonderful, but approximately where would you locate your mean? Well, I'm looking at my data in my 1 var stats, and I know that my mean is at 50 and 375 thousandths with the number that I've put in. Okay? Now, it does not show me the picture of my graph. It does not show me my bar. But it says, how does the direction of the tail affect the location of the mean age compared to the median age? So the mean is down here at 50. My median is at 60. Okay? So the mean is typically in the direction of the tail. So the mean age would be to the left. So really what's happening is I've got this number here down at 6. And then it's a long way away to 40. And then my Q3 is at 70. So there's only 30 places between these. There is 34 here. But then the max number is short. It only goes up to 75. So when they say which way is the tail is definitely leaning towards the left. There's a lot of different variability down here. And then we've got 51 right here, 51, 50 and 375 thousandths. So it helps to have that box and whisker plot. Okay, this box and whisker plot's going to stay there for when we come down to questions here. So the mean age of the above sample is approximately 50. Do you think this describes the typical viewer of the show? Explain your answer. So here's what we want to figure out. Does this describe the typical viewer? I would say absolutely, because if we're looking here, 25% of our people are in between 40 and 70. So could we come out halfway and be like 55? Sure, 55 is a great estimate, but 50 is not that far off. So is that a good age? Absolutely. Okay, 30 people in here, or 30 different ages in here. Halfway is 55. Is 50 relatively close? Sure it is. Okay, so I drew the box and whisker. It's asking us here to draw it. Okay, well, we already did this. So using the above dot plot, construct a box plot. And they're calling it a box plot. It's a box and whisker. Whisker, box, whisker, just so you know. Locate the middle 40 observations. Well, that's 50% of my stuff. Does that make sense? Well, if there's 80 viewers, 40 of my numbers are going to be in the middle. Well, yeah, because that's Q, starting at Q2, going up to Q3. Okay? And they're actually calling that the lower quartile, but it's fine. So now it says the minimum age. The minimum is my low end of the range. The lower quartile, which is where it starts, is 40. The median, median is different than our mean. So now we're coming back here, and it says my median is 60. The upper quartile is 70, and my max is 75. And yeah, I'm going to check my answers because sometimes I don't believe myself. No, I'm good. Okay. So then it goes to these next questions that say, what percent of the data does the box part, does this part capture? Well, remember, from this edge to this edge was 40. So how much is in there? 50% of our data is in there. That is extremely, extremely important. What percent of the data fell between the minimum and Q1? Well, 25%. What about between Q3 and the max? Well, also 25%. We need to understand that in a box and whisker, what they're calling a box, they're calling a box plot. I don't know why. 25, 25, 25, 25. You can figure out the number of people in between each of those. So if we know there's 80 people, we know there's 20 people between 6 and 40, 20 people here, 20 people here, 20 people here. Or at least it should be. That's what we're figuring out with box and whiskers. Okay? Now, sometimes in statistics, there are anomalies. Okay? An anomaly meaning that it should not count towards whatever you're doing. So we've had anomalies in our class. So the last test I had 2 bonuses. And then I gave you time. I told you, hey, use your notes, come back out, let's see where we can go. Well, there was an anomaly already because before I gave them back, the highest grade was a 90%, except for one student who had already scored 106. Most of my scores were somewhere between like a 65 and an 80. That's where most of the scores were. Did I have some lower? Sure. Did I have some higher? Yes. But then I had this 106. It stuck out like a sore thumb. That was skewed. That one is what would be considered an outlier. So this right here says students at Waldo High School are involved in a special project. Here's 200 randomly selected people from Kenya. These are 200 randomly selected people. A data distribution may contain extreme data, specific data values that are unusually large or unusually small to the median and the interquartile range. A box plot can be used to display extreme data values that are identified as outliers. Each asterisk in the box plot represents the ages of 4 people from this sample. Based on the sample, these 4 ages were considered outliers. Okay, so these are 4 different people. And based off of everything else, there's really 196 here. So there's still 25%, 25%, 25%, 25%. These 4 are so high, especially this one. So here's like, this is probably like 62. This is probably like 72. And they get higher from there. This is really the biggest outlier. This is multiple standard deviations away from the mean. Okay? And you should know what we did with that because we've talked about standard deviation. Okay? So for reasonable estimates, these aren't part of our average, which is like 18. Yeah, okay, it goes up. There's still 25%, but these are so far out of what would be considered normal, we don't necessarily want to use them in our data. Okay, so box and whisker, box plot, whatever you want to call it. Whisker, low end, high end, quartile, quartile, interquartile. The first quartile range, the upper range, which is the 4th quartile, they call it from the 3rd quartile to the range. Okay, we're going to be dealing with these. We're still going to be doing some of the problems on the problem set because I personally like dealing with this. I think it's a lot of fun. Hey, hopefully you take good notes. If you have questions, as always, make sure you ask.